Right, welcome. I'm Mr. Simons. In lesson 3, we'll be looking at multiplication and division of exponents, or problems that look like this. They are very common, as in grade 10, as grade 11. They still pop up in grade 12 exam questions under question 1. Right, so we go to the first slide. Right, so before we can solve any problems, we need to know what's prime factors. I assume you still remember what's prime numbers. So to simplify the exponents, when you multiply or divide, all bases must be powers of their prime factors. So if I take 45 for example, 45 can be written as 5 times 9, but 9 is not a prime number, so therefore it becomes 5 times 3 squared. Right, as can be seen above, 5 and 3 are both prime factors, therefore 45 is now expressed with its prime factors. On a Casio calculator, the FX for 82 going upwards, you'd press 45, press the equal sign, then press shift, fact should be above. You see there's all these round circles and commas, and the calculator would then show you 45 is 3 squared times 5. So that can be done on a calculator if you're not sure of your prime numbers or your multiplication or timetables, right? Right, problem number 1, I've given you 25 to the power n minus 1, n minus 2, 27 n plus 1 and 5 negative 1 divided by 75 raised n minus 2, 9n plus 2. So step 1, you'll always have to express all of this as prime bases, meaning we only have prime numbers. So 25 should know is 5 squared. 27 we should know is 3 to the power 3. Right, 5 is already a prime number, so stays as it appears. 75 become 3 times 5 to the power 2, and then 9 would become 3 squared. So that's expressing as prime bases. So all grade 11 problems will start with whether we can express as prime bases. Right, the rest we apply the laws. I just now generally call it the 4-3-2-1 problem. So we go in that order. Right, now this is where most learners go wrong, so follow very carefully. There it's 2 times n, which gives me 2n, and 2 times negative 2 gives me negative 4. Learners forget to multiply the exponent inside with both exponents outside, and that is where we pick up when we mark where you've made the error. So there again, 3 times n gives me 3n, 3 times 1 gives me 3. That simply stays negative 1. There again, here's where we'll catch you out again. So it's invisible 1. 1 times n is n. 1 times negative 2 gives me negative 2. 2 times n, 2n. 2 times negative 2, negative 4. So everything inside must be multiplied with everything outside, right? There again, 2 times n gives me 2n. 2 times 2 gives me 4. So that is step 2, applying law 3 and 4, multiplying in and out. Right, there's it there. Can pause and just refresh. Right, and then we apply law 1 and law 2 together. So I'll start there with base 3. Everything on top is written as it appears. So I have 3, 3n plus 3. If I come below the division line, I change the signs, because second law states I must subtract. So the positive n becomes negative n, negative 2 becomes plus 2. 2n becomes negative 2n, plus 4 becomes negative 4. So that's all the base 3's. Then base 5, so 5, 2n minus 4 is on top, stays as appears, minus 1 on top, stays as appears. Come below the division line, I simply change the signs because I'm subtracting. So plus 2n becomes negative 2n, negative 4 becomes plus 4. Right? Now, most exam questions, the variables must cancel, but some of your problems in your textbooks, the variables will still stay. So the 3n minus n gives me 2n, 2n minus 2n, all the n's cancel. 3 plus 2 would give me 5, 5 minus the 4 would give me 1. There 2n minus 2n, the variables again, they cancel. Minus 4 minus 1 would give me negative 5. Negative 5 plus 4 would give me negative 1. Not allowed to have a negative exponent as a final answer, so we drop it to the bottom so it becomes positive. So my final answer, 3 over 5. So as you can see in algebra, pattern recognition, there's the steps. Get used to them. I'm going to do another 2 problems and hopefully you'll get used to it. And then you can go practice the problems in your textbook on this in relation. Right, so there for problem 2, we've given you 45, which is not a prime number, 75, 25, 15, and 3. So we have to express step 1 as prime basis. So 45 is 3 squared times 5, n minus 3. 3 there as an invisible exponent, 1. 75 again would be 3 times 5 squared, 4 minus n. 25, we assume you know, is 5 squared minus n, and 15 as prime numbers would simply be 5 times 3. Right, now be very careful again, take note. To apply law 3 and law 4, we're multiplying all exponents inside with exponents outside. Be very careful with your multiplication. Don't lose concentration, don't lose focus. So there, 2 times n gives me 2n. 2 times minus 3 gives me negative 6. Then I must still do the same with 5. 1 times n gives me n. 1 times minus 3, minus 3. That stays as appears. There 1, that's 3 to the power 1. 1 times 4 gives me 4. 1 times negative n gives me negative n. 2 times 4 would give you 8. 2 times negative n gives me negative 2n. 2 times negative n would give me negative 2n. 1 times n plus 2, anything times 1 stays the same, n plus 2. 1 times n plus 2 gives me 3n plus 2. General, there's the difficult part done. Now we're going to the easier part. So I'm going to take all my base 3's on top, they stay as they appear, the exponents. Come below the division line, that line there, we change the signs. So there 2n minus 6 stays 2n minus 6. 1 stays positive 1. 4 minus n stays 4 minus n. But if I come below the line, that n plus 2 now becomes minus n minus 2. With base 5, n minus 3 stays n minus 3. 8 minus 2n stays 8 minus 2n. It's above the division line. If we come below the division line, minus 2n becomes plus 2n. n plus 2 would become minus n minus 2. As I said, most of the time the variables cancel in every exam question, but there's an exception in your textbooks. So 2n minus n gives me 1n. 1n minus n becomes 0. Minus 6 plus 1 would give me minus 5. Minus 5 plus 4 would give me minus 1. Minus 1 minus 2 would give me negative 3. n minus 2n would give me minus n. Minus n plus 2n would give me n. n minus n, all the n's cancel, the variables cancel. 8 minus 3 would give me 5. 5 minus 2 would give me 3. So most problems you're going to solve will at least have one negative exponent at the bottom. My final answer is not allowed to have a negative exponent. So that is positive, it stays on top, 5 cubed. Negative 3 I take to the bottom to become positive 3. The question says simplifies. 5 cubed would be 125. 3 cubed would be 27. So I hope you follow the steps. The third time, and this is what you're going to apply to all your problems where it's multiplication and division of exponents. Alright, so problem 3 again, 25, not a prime number. 6 not a prime number, 10 not a prime number, 15 not a prime number. So step 1, can we express them as prime numbers? So 25 would become 5 squared. Remember on your calculator, 25 equal, press shift fact and the calculator would give you 5 squared. 6 is simply 3 times 2, 10 is simply 2 times 5, and 15 is simply 3 times 5. Then very careful, this is the step where we go wrong. When we mark your papers, most learners made the error there. So multiply everything inside with everything outside. So 2 times x gives me 2x. 2 times 1 gives me plus 2. 1 times x gives me x. 1 times x gives me x. There 2. 1 times anything stays the same. For base 5, 1 times anything stays the same. Base 3, 1 times x. Base 5, 1 times x. Alright. Now I'm going to start with base 2. Everything on top is written as it appears. At the bottom we change the signs of the exponent. So that is positive x minus x plus 1. For base 3, on top stays as appears x. Come below the division line, change that to negative x. For base 5, 2x plus 2 on top stays as appears. Come below, positive x becomes negative x, minus 1 plus 1, and x negative x. So x minus x cancel, I'm left with 2 to the power 1. X minus x gives me 3 to the power 0. 2x minus x gives me 1x minus x would become 0. 2 plus 1 would give me 3. Alright, so 2 to the power 1 stays 2. Anything to the power 0 will become 1. 5 to the power 3 simply stays 5 to the power 3. So 125 times 2 would then give me 250. Hope you follow. Hope you understand. Get used to the procedure. As I said, algebra is pattern recognition, so all your problems that you see looking like this, expressions, you're going to solve in that order. Okay, nothing but the best for you.